So I didn't quite finish this last example, so I just plotted the minimum again. I had plotted the first quartile, which is 4.5, the median is 9, quartile 3 is 13, and the maximum is 16. So I'm going to put my whisker, and by the way, sometimes on these whiskers they put a little tail here. That's most of the time they do that. I should probably have done that up above quick. And then I'm going to connect my boxes in the middle. Now you might be asking, so what's the whole point of this? The whole point of this is, again, to break down the data into smaller subsets. And so we know, and I'll go back to the example up here, notice the whiskers are different sizes, the boxes are different sizes, and so when you look at, again, here's the first subgroup, here's the second subgroup, here's the third subgroup, and here's the fourth subgroup, the 100th percentile, the 75th percentile, the 50th percentile, the 25th percentile, and the 0th percentile. You don't want to be like me. I was down here in high school. I wasn't that low, but you don't want to be down there. At any rate, so what does this mean? All it means is people in the 25th, in the bottom quartile, again, what's a quarter? It splits $1 into 4 pieces. Here's one piece. In the bottom quartile, there's one value. Where is it? It's the number 1. I'm just going to grab that marker. Did I switch colors here? It's not letting me switch colors. Let me grab pink here. Can't grab the red. So in this grouping, there's one value. What is it? It's the number 1. It's sitting right here. There is no 1.5. There's no 2. We don't include this value. We start at the bottom and we go up to this point. This is the separator. What's the separator? It's 2.5. In the next group, from 2.5 to 5, there's one number. What is it? It's 4. It's this number right here. So I'm gonna highlight these numbers that are up above. Here's the first one. There's one number in this grouping. There's one number in this grouping. This value is a separator. The middle is always a separator. And it is 5. There's that value. It's not in this group and it's not in that group. There's one number from 5 to 9, and that number is, I think I did this wrong. This should have been over here. At any rate, 9.5 is the quartile 3, but there's one number from 5 to 9.5. It is the number 9. It's sitting right here. And there's one number in this grouping from 9.5 to 10, and that is this number right here. So my pink outlines the numbers, and you can see there's the same amount of numbers in each group. There's one in this group, one in this group, one in this group, one in this group, as is indicated up above. Now, if we look at this one down below, the boxes are not the same size, but I'm telling you, there is the same amount of numbers in every single box, in every single whisker, and we can highlight that. So, from 1 to 4.5, there are two numbers. Here they are. Where are they? There's one here, and there's one right here. Okay. In the next grouping, there's two numbers. One at 5, one at, and that would be right about here, and one at 9, which would be right about here. Well, it's right here actually, I lied. So you can see there's two numbers here, two numbers in this grouping, and then in this grouping there are two numbers again. Now even though 9 is not here and not there because there's two of them, we can assume one's here and one's here, but there's at 9 and 12, so you can see there's two numbers in this grouping here, two numbers in this grouping, and two numbers here in the last is the number 14 and 16. So 14 must be up here somewhere, right in the middle actually, and here's 16. The message I'm trying to send, even though the whiskers are different in size, even though the boxes are different size, it still holds the same amount of values. we have 25% of the values here, 25% here, 25% here, and 25% here. The spread, the range in each box and whisker is going to be different. It just says some are more spread out than others. So I'm going to jump down to this example right here. We do this in class always, and I have you do it at this point in time. This shows grades from, say, period 1. I don't remember what grades these were out of, and I always update it every year. And I'll just say, here's period 3. It could have been period 1, period 8, period 3, period 8. It doesn't matter. So I'm going to go plot the box and the whiskers for each class very quickly. I've already kind of cut it up a little bit. So here's my quartile 1. Here's my quartile 2, which is 81. It's right in between. The average of 81 and 81 is 81. Here's quartile 3. Here's my max. Here's my min. Now, the whole point of Box and Whiskers is usually to compare groups of data. So I'm going to compare period 1 and period 3. It'll give us a visual. I've already done the numbering system. I went from 20 to 100. You say, why did I go to 20? The lowest is 33. Well, it's easier to subdivide by even numbers than it is subdivide by an odd and an even. So 33, here's 30, so I'm going to put this one on top. So there's about 33. 79 is the next value, 70, 80. There we go. 79 just a little bit to the left. Then I'm looking for 81, which is a little bit to the right. Then I have 83, which is right about here. And then I've got somebody really worked hard and they got a 95. So I'm going to do a little box and whiskers, just like so. Now notice how close these boxes are. And look at how long this whisker is. So what we have here is we have a very good class. We have a lot of high scores. Let's go do the bottom real quick. So 64 is right about here. We have 66 as quartile 1. That's right about, I did this wrong. Here's 70. 64 is here. And 66 is probably here. And again, you don't have to get these exactly marked out, but you want to get them close. You want everything scaled properly. Then we go, what's the middle of 71 and 78? That's a difference of 7. Cut it in half is 3.5. I'm going to add 3.5 here or subtract 3.5 here. That puts me at, wait a minute. This difference of 7, 3.5 is 74.5. So my middle is 74.5. Here's 70, here's 80, 74.5 is right kind of in the middle here. Then I have 84 for my quartile 3, which is right about here. And 93 was the high score for this class, which is right about here. I'm going to do my whisker. I'm going to do my boxes. I'm going to do my whisker. Now, when you look at this, now notice there's what? There's 10 grades here, and there's 10 grades here. I'm comparing 10 students from this class, 10 students from this class. Look at it. How many numbers are in this range right here? Well, the answer is 2. How many numbers are in this range, in this box right here? The answer is 2. How many are in this box? The answer is 2. How many are in this whisker? The answer is 2. Now what you have to understand, even though the whisker is longer here than it is here, and even though this box is so small, I still have 25% of the data in each subgroup. That's what quartiles do. Put 25% into one group, 25% of the values into another group, 25%, and 25%. So what you see is an even distribution of the values, but the range of values is much different. So when you look here with a minimum score of 33, you just had one student who just blew off the quiz or whatever the case might be, and it made everybody else look bad. We can ask a whole host of questions of which students did better, but let's just talk about this for a minute. So 25% of the students were in this range here. What is this number? This is the middle. This is the 50th percentile. Half the kids did better than 81. That's my middle. Half the kids did better than 81. Half the kids did worse than 81. But where is quartile 1 showing? In other words, quartile 1, even though half the kids did less than 81, 25% of those kids had a C plus or a B minus right here at 79. So 25% of the kids got below a 79. 25% of the kids got above an 83, because this is our quartile 3, and you have to reference these numbers. So, which class did better? Well, there's a lot of different answers. Here, this class did better because they had a higher grade student. This class did better because the top 25% did better than their top 25%. You could say this class did better because their lowest quartile is higher than their lowest quartile. So let's look at some specific examples with a specific example. So here is students' heights. So we got the boys versus the girls, males versus the females, and so they're going to ask us a series of questions. So let's go along and look. Now, in general, what do you notice? In general, looks like the boys are taller than the girls. We see it at every quartile divider. The median, the quartile 3 is larger, and the maximum is larger. And these are centimeters, by the way. Thought we'd do a little metric system. Which ones are true and why? So the girls are taller on average than the boys. True or false? Think about it. Pause. The answer is, this word here, this could be a little deceiving. Does the box and whiskers give us an average? No, it doesn't. So in theory, I don't know if we can answer that. If they said the girls are taller in general, I would say that's false. If they said in general instead of on average, that would be false. The girls in every divider, in every quartile, in every maximum and minimum value represented are not taller. They are shorter. The boys are taller in general. And I think that's the word they should have been using here. I would say, yes, that is true. The median is greater than the median. Quartile 3 is greater than quartile 3. Maximum is greater than the girls' max. The girls show less spread in height. Well, spread is the range. What's their range from here to here versus from here to here? Now, without calculating, they look like their range is pretty equal. I would say the boys are a little bit more spread. They have a bigger range. Looks like the distance from here to here is a little bit more than from here to here. So I would say the boys are a little bit more spread out. So I would say that's false. Oh, no, that's true. Less spread. Read carefully, wits. The boys show less spread. No, the boys show more spread. It's wider. Just measure from here to here. Measure from here to here. I can guarantee you it's more. We can see it visually. That's why I like the box and whiskers. The shortest person is a girl. Well, let's look at the shortest person in the boys. Let's look at the shortest person in the girls. That's true. You look at the minimum. The tallest person is a boy. Compare the maximum to the maximum. That's a true statement. Both data sets are skewed to the left. We're not going to talk about skew. Half the boys are over 172. Well, here's my 172 is right about here. Half is to the right. half is to the left.